class and double check, make sure the recorder is working. Yep, it is. All right, so this is a continuation. We are going to finish up the control structure topic and then move on to file input output today. This is the very last topic, nesting control structures. And the first slide, or the first program that you see on this slide here, is something that looks like this, okay? Which most of us, using the indentation can kind of know, what it means. And by the way, this program has a problem, which is I is not initialized. It is actually okay to declare variable I within a for statement like this. It is actually okay in C++, but it is not okay in C. So if you do this in C, it will complain, but in C++, it is actually okay. All right. But other than that, we are more kind of interested in the structure of the code rather than, okay, is I going to be initialized by the time we compare, which it is not. Okay, it's not going to be initialized. What we want to do is to look at things from the perspective of the compiler. Okay, because a lot of times we look at these programs and we see it as people, and use indentation to help us understand, okay, which one is inside which other one, which can be very, very misleading because the compiler does not see things exactly the same way. So instead of reading this program using the indentation, and this is something new for this particular section of the class, I didn't do it with the other class, is I'm going to write this program. Okay, I'm going to change the program a little bit here, just so that it makes more sense. But otherwise, the structure of the code is the same. But instead of writing this program in different lines, in 3 lines, I'm going to write it on one single line with just the spaces to help us understand, okay, this is different from that one. Okay, so instead of looking at this program like this, let's look at this exactly same code, well, not exactly the same, but similar code, but using a single line, which is perfectly okay as far as the compiler is concerned. This won't be the first time. Well, this won't be the last time that I say this. I would say this again and again. As far as C++ and C is concerned, line feed and indentation is nothing more than a single space, functionally. Okay, it's just there to separate something. That's all. Okay, so when you think of indentation, it's like, oh, it indicates how nested a particular statement is. To the C compiler, it has no meaning whatsoever. Line feed has absolutely no meaning either. Okay, so when you look at a program like this, the C compiler is actually looking at the same program in this particular way. So what we want to do is to say, okay, what is the compiler actually seeing? How is it interpreting this code? When the C compiler encounters this particular keyword for, it immediately understands, okay, I am looking at a for loop here. Because no other statement can start with the word for, okay? Which also means, you in C and C++, you cannot name a variable, using the same name. Okay, all these keywords, for, do, while, switch, if, else, you cannot name variables with those names. So right away, the compiler says, okay, I can see this word here, it is for, which means I can expect the following. In other words, the compiler anticipates, what else it should be seeing. It will be the open parenthesis, 3 expressions within the parenthesis separated by semicolon, by 2 semicolons, close parenthesis, and a single statement. That's what the compiler is telling itself. I need to expect these things. So as it parses this particular program, it will find all of those things because it will see the open parenthesis, it will see the initialization expression, it will see a semicolon here, it will see the condition to evaluate, which is, this has to be true to stay in the loop. It will see the other semicolon, it will see the post operation as an expression, it will also see the close parenthesis. So right at this point, the compiler is pretty happy, saying, okay, I'm finding everything that I've been expecting, and I need to find a single statement now. And when it's trying to find a single statement, it sees the word if, which is the beginning of a conditional statement. And the compiler says, that's fine, okay? I just need a statement as a part of the loop. a conditional statement is just as good as any other type of statements, which is not a problem. But now it is nested. In other words, the compiler has not finished parsing the for loop yet, and as a part of the for loop, it is now finding a conditional statement as the body of the for loop. Is that part okay? It's kind of like having an open parenthesis that has not been closed yet. Okay? So at this point, the compiler says, oh, I know conditional statements. It starts with the word if, followed by open parenthesis, a condition, a closed parenthesis, and a single statement. Okay? So now it will start to look for those things as components of a conditional statement. And we don't have a problem with that, right? We have open parenthesis, we have a condition, we have closed parenthesis, and by the time the compiler gets to the letter n, which is all by itself, it now tries to match n with all the things that it knows. Okay, it's not for, it's not if, it's not do, it is not while, it's not switch, which is one of the statements that we haven't talked about. It's not go to. Okay, it must be a variable. So the compiler now understands, okay, I must be expecting an expression statement at this point because it's none of the control structure that we have talked about so far. Is that making any sense? So if it's not one of those things, it must be just an expression statement. As an expression statement, it is now finding the operator and then the right-hand side of the assignment, and within this, it also finds this is an expression. So by the time it finishes this entire portion, the compiler would find it would have parsed an expression. But an expression is not a statement, okay? And yet we want a statement. And that's why the semicolon is so important, because if you follow a expression with a semicolon in this context, it becomes an expression statement. Now, this is important. By the time the compiler parses this semicolon, it would close three different things. The first thing, the most immediate one it would close, is the expression statement itself. Okay, that's the lowest level statement. And the compiler says, woohoo, I got an expression statement. But wait a second here. This expression statement is a component of the conditional statement, because a conditional statement can have one single statement. So it would then close the conditional statement because we're not finding the word else after this. Okay, so it would close the conditional statement, and then it would say, oh, this is the component of the for statement, because a for statement is expecting only one statement. In this case, it is the conditional statement. So that's how the compiler sees things when it parses all of these characters when a program is compiled. Are there any questions about the general idea of how a compiler sees a program or sees code like this? Okay. Well, that's not very difficult, and most people would even argue and say that, hey, this is easier to read. Okay, I don't even have to read the program like a compiler, and I still understand how things are grouped. Okay, fine. Let's move on to a slightly modified version of this code. In other words, let's say I wrote this program initially, and then later on I found out, oh, you know what, I forgot to do one more thing inside the conditional statement. I also want to subtract 1 from m when I'm adding 1 to n. Okay, simple mistake, I know how to fix it. So in order to fix that mistake, I'm just adding one more line. M gets m minus 1 right after n gets n plus 1, and I've even used the right indentation. As far as a person is concerned, that seems to be the right thing to do. The compiler will compile this, okay, assuming all the variables are declared. It's not a problem. Syntactically, this is 100% valid, but it doesn't do what you think that it might do. Okay, what do you think the compiler is going to do in this case? How are these statements related to each other?
Is the m equals n minus 1 the else branch, and it's not going to perform it?
It's not in the else branch, because in order for something to be inside the else branch, the word else has to be there.
Isn't it by itself?
It is all by itself. In other words,
outside, isn't
it is outside of the for loop. In other words, in this case, this for loop ends here. This is a statement after the for loop. It is performed only after I is no longer less than 3 and we get out of the loop. And this is the worst kind of problem. Well, not worst, but one of the worst kind of problem, because the code does not have any syntax error. the compiler cannot catch it and say, oh, hold on a second here, this doesn't work. Okay, it cannot even give you a warning. Okay, it won't even give you a warning because there's nothing to warn about. This is perfectly okay. And if you look at the code syntactically, not syntactically, but using the indentation, it seems to be suggesting that m gets m minus 1 is a part of the then branch of the conditional statement, and yet it is not. So this is the kind of stuff that you have to watch out for when you nest a control structure within another one. Is a lot of times C, the syntax of C is very lazy. It just says, oh, this is a for loop, we expect one statement. And that statement, if you don't use a block statement, it is just one statement, as in one single statement. And the same thing with a conditional statement. So the way it works is the compiler sees the for keyword, it expects a open parenthesis, it expects initialization, condition, post operation, close parenthesis, and a single statement. Oh, it's a conditional statement. No problem. I can handle a conditional statement. And a conditional statement has the if keyword. It has open parenthesis, a condition, close parenthesis, and a single statement after that. And which single statement are we talking about? N gets n plus 1. So by the time the compiler sees this semicolon, it would do the same thing that we already talked about. It found that, oh, I have a statement here. This has to be the statement inside the conditional statement. So this becomes one entire statement, and this entire statement becomes the statement of the for loop. So the for loop only goes up to that point. Okay? Syntactically, it will say, oh, I can have an assignment statement after the for loop. That's not a problem. It's just not a part of the conditional statement, nor a part of the for loop. And this kind of mistake is very easy to make because when someone thinks, oh, I don't need not parentheses, but curly braces, because it is so clear that I only got one thing to do in the loop. I don't want to have to type open curly brace and close curly brace. And that type of mentality can easily lead to problems like this. It's not the first time when you write a program that you end up with code like this. It's when you need to add something to your code and you forget about, oh, okay, in C and C++ you need curly braces to include multiple statements within a block. That's when problems happen. Are there any questions about why this code is problematic? So the question is, how do we fix this problem? How do we avoid getting into this kind of problem to begin with? So let me just kind of show you what I would do, when I'm to write the program, the original code like this. So the way I do this is I would do it in a structured way. And when I say structure, I start with this. I start with the entire framework of a for loop. Okay, the open curly brace, close curly brace, for, and then the semicolons within the parentheses. Then I go back and fill in, all the content. Okay, so to make it exactly the same as the code already on the notes, this is how I write it. Okay, now I have to specify what is inside the for loop, and it's a conditional statement. So when I write a conditional statement, I start with this. Okay, it's the entire framework of a conditional statement, including a place to put the condition, a place to put the then branch, and a place to put the else branch. Now, whether I have actually something to do for the else or not, I still put it here. Then I go back and backfill the components of a conditional statement. So I, the same as k, is here, and then we get, n gets n plus 1, and that's it. Okay, that's the original code. But I would put in all these extra pairs of parentheses, even though when they are not needed. Now, if I wrote the original code like this, and then later on I found out, I forgot about m, I need to decrement m, when I add 1 to n, well, this would be the right place already. I don't need to worry about the problems that I was talking about earlier because of the extra curly braces. Are there any questions about, why, this particular approach of writing code can avoid problems to begin with?
Do you still recommend putting the else if there is no normal statements for that?
Well, if you cannot think of something to do for the else at the time, it doesn't mean that you may not think of ways to use the else branch later on. This just makes it so much easier in case you think of, oh, you know what, the else is a there's something to do for the else. Then you don't have to worry about, where do I put the else? Am I in the right scope? Is this else corresponding to this if, and so on? It's already done. You just have to, you have a place to put it already. Is that making any sense?
Yeah.
Yeah. It's kind of like, preparing for modifications or, stuff that you have not anticipated ahead of time, and you have a place to put it already. It's not something that you have to do. If you turn in a program that does not look like this or use the same method, I'm not going to take any points off. It's just, basically stuff that I have learned over time. This works well for me. When I write code this way, I avoid a lot of problems, that can happen down the line. It doesn't take up any additional execution time. In other words, you look at this else here and say, wow, that's like 3 lines of doing absolutely nothing. Well, in the source code, it is just wasting 3 lines, but in the execution code or in the executable code, it's not doing anything. The compiler does not generate any extra code for this, so it's not going to run any slower than the other way. And yet, I have a place to put, some code that, in case I need to, I have a place for it already. Are there any questions at this point about this approach of writing code? It's not the only way. It's not quote unquote the right way. It just works for me. Yep.
So if we were looking at I think it's the object code, would not produce any bits, that else branch?
No. If you look at the object code, this would have done exactly the same thing as putting just curly braces around these 2 lines. Yeah, the compiler is pretty, it doesn't even have to be very smart, because to recognize there's an empty block is pretty easy. So it doesn't really do any extra work or
Just
produce any extra code.
It just nulls it if it's empty.
Yeah. All right. So are there any questions about this code? There's another example to show you, how nesting can be a little bit tricky. If you look at this code here, the indentation suggests that the conditional statement is a part of the loop, but it's not. Okay. In this case, it's the same way. I find the word for as the compiler. I expect open paren, initialization, condition, post operation, close parenthesis, and then I'm expecting one single statement. Okay, I see m gets m plus 1 semicolon is an expression statement. That's the one statement associated with the loop. So that will end the loop itself. So the for loop will only be this much code. What about the conditional statement? The conditional statement is performed after the loop exits. But the indentation seems to suggest that the conditional statement is a part of the loop. Okay, now this is something that some of us have to kind of pay attention to, especially when we use pseudocode or Visual Basic in the previous class. Because in pseudocode we have for if and end if, which is very clear. This is the beginning of the if, this is the end of the if. But in C and C++, it just says, okay, after the if, there's one single statement. There's no explicit end to the if. So it's not, in terms of how visible it is, it's not visible at all. How many people use pseudocode in cisp360? Okay, I know I use pseudocode in my class. What about the other classes, cisp301, or those of you who took P300 from other instructors? What did they use to teach? Pseudocode? So in the pseudocode, do they have like if and then the and if? Okay. Anyone else? Pseudocode? Okay. So in most pseudocode, they have an and if because it just makes it visible, like this is the end of the conditional statement. But C doesn't do that. C just says, okay, I'm expecting one statement. If you have more than one thing to do, make it a block statement. And that's why we have the curly brace to basically turn multiple statements into one single statement. It's like a folder, basically. All right. So if there are no questions, I'm pretty much done with all this stuff here. The rest is really just repeating what I said earlier, verbally, except it's all typed up. So there's nothing really new here. Okay, but here's a question. Over the course of time, when you're writing programs, at some point you're going to mess up the indentations of your program. I mean, it's just bound to happen. So unless you keep track of the indentation of your program carefully and make sure they're all correct, at some point your indentation is going to be off and it doesn't indicate how your code is nested anymore. So what do you do at that point? Okay, there are a few options. The first option, which is to leave it the way it is, the indentation is wrong, but I think I can remember that. Okay, that usually does not work out very well because most people will forget about the wrong indentation, and then later on, that person will look at his or her own code and misunderstand about the nesting of the statements. Okay, so that's not really a very good option. The second option is to do it, fix everything manually. If you try to fix everything manually, having a good editor really, really helps. Okay, some editors are better than others. Like VI is really good because it can match the curly braces. So, it allows you to jump from a open curly brace to the matching end curly brace also, which is a really, really nice feature. Okay, you can also use what we call code beautifiers. Okay, and that's an actual term. Okay, it's called program beautifier. So you basically give a beautifier program tool, a program that is not indented correctly and doesn't follow all the formatting that somebody is recommending, and then the output of the beautifier would be a program that is properly formatted with the right indentations. So there are programs like that. Some of you do not believe what I'm saying here.
No, I'm not looking at you because I don't believe you. I'm just saying that could cause problems if you let a machine do it, especially if you messed up on your code.
Well, it does a fairly good job on what it is supposed to do. Okay, best code beautifier formatter. I would
sure
not.
It does. It's more. I think I'm more worried about human error. Like,
But it would make it visible, because by making the indentations correct, when you look at the output of a beautifier, the indentation will be correct because it will analyze the structure of the code and indent correctly based on the structure of the code. So it is a useful tool. I would not overuse it. Like rely solely on the tool to do the indentations correctly. I will only use these tools when I have to restructure a piece of code so dramatically that it would be difficult for me to do it manually. Otherwise, I'll just do it manually. That's also when VI is a nice editor because it allows you to do indentation by a block. You can say, I want to indent this block of code by one indentation without affecting the rest of the program. Yep.
Are there such things as compilers that recognize indentation?
The only programming language that I know of that uses indentation itself to indicate nesting is Python. And Python, as popular as it is for web scripting, is still relatively limited in terms of what you can do with Python. But C, C++, Java, JavaScript, Perl, PHP, those are all C-derived languages, and they all follow the same rules as C and C++. So for the most part, the majority of programming languages out there do not recognize indentation as an indication of nesting. It is just for your purpose so that you can visually see how your code is is nested. So for the most part, you still have to pay attention to indentation. There are tools out there that can help you with indentation, like when you type open curly brace, it automatically closes the curly brace and indent the code in the inside. But at some point, you can still mess up the indentation. So you still have to pay attention for the most part. Any other questions about what we have just talked about? Now, there are some control structures that I have not talked about, and I do not have any real intention to talk about those unless we have time at the end of the semester. One is called a switch statement. A switch statement is basically a fancy way to do conditional statement. So you can basically say, okay, if n equals to 1, go here. When equals to 2, go here. When n equals to 3, go here. But you can do it with a conditional statement as well. Okay, so it doesn't really add anything other than clarity to your code, and it can also add confusion. Okay, switch statements can also lead to a lot of confusion, which I don't really like, and that's why I don't talk about it. Another statement is called goto. Now, goto is interesting. GoTo is just GOTO, otherwise known as the G word, because we don't really like GoTo. It's kind of like cursing in programming, the G word. Don't use the G word on this program. It's because it can lead to spaghetti code. Okay? It's a very handy feature to fix a few things. It's like, oh, when this is true, I really need to go all the way down here instead of exiting the loop step by step, level by level. But any program that makes use of GoTo and a label to go, as a destination, eventually becomes basically unmaintainable. Okay, and everybody will go, everybody who uses GoTo always starts with a statement of, I know what I'm doing, I'm only using it here. And that's famous last words. Okay, because eventually, get abused, and then the program becomes, completely unmaintainable. And I understand that part probably as well as, any other person, because I have dealt with programs, single subroutines, like 300 or 400 lines, with GoTos everywhere. Okay, it would do a GoTo nested inside the control structure into another nested structure in the inside. So it's really, really hard to track. And eventually I had to delete the entire code, the entire subroutine, and replace it with my own code. So don't use GoTos. That it really has no place in structured programming. The moment you introduce GoTo into a program, it is no longer structured. And the same thing, personally, also applies to a break statement and a continue statement. You will probably hear those statements from other professors and other people. I try to stay away from those as well. Okay. So for the most part, we have talked about all the essential control structures, and now we are moving on to the next topic, which is actually boring. We're not moving to more exciting topics. We're now moving back to a super boring topic. Input and output. Now, most people look at input and output, file operation and say, "Oh, that's exciting." Well, let me ask you this question: is it more exciting to talk about branches? Okay, here's a decision point. You can make a left turn, you can make a right turn, and then you can make a loop going back to the same place and do it again and again. Or is it more interesting to talk about a conveyor belt? This is a place you can put something onto the conveyor belt, and this is a place you can take something away from the conveyor belt.
You gotta understand the conveyor belt if you're gonna build an assembly line.
It's an assembly line, it's a conveyor belt. It's just that what you put onto the conveyor belt is a byte by byte. Okay, you can say, oh, I want to put this byte onto the conveyor belt. Put another byte on the conveyor belt. Put another byte onto the conveyor belt. And then on the other side of the conveyor belt, you can say, oh, okay, I guess it's time for me to take another byte out of the conveyor belt to process it. Okay, now I'm ready for the next byte. Take it out, process it, and so on. Okay. That's files. Hold on a second here, Tag. That's not how I understand files. Because the way I understand files is it has a name. It's we save a file onto a hard disk drive. It has a name. It lives in a folder. It represents graphics and documents and spreadsheets and all those exciting things. Well, that's one type of way of looking at files. But in principle, a file in programming is nothing more than a conveyor belt. It is just a way to store, or I should not even use the word store, because a file doesn't have to store anything. There are files that does not store a single thing, has no name, does not live in a folder, and yet it is a file. Okay, and in C and C++ programming, those are the files that you get to encounter first, not your typical file. It is the weird files that have no names, no folders, no way to refer to them other than C in, C out, standard in and standard out. Okay, so we'll start with this really kind of boring slide here of what exactly is a file. Stay on this page. Okay. Well, I did not think of the analogy of a conveyor belt, so that's why you won't find conveyor belt anywhere within this slide. But if you have to remember one thing about a file, it is a conveyor belt. Now, some conveyor belts eventually lead to a box where whatever you put onto the conveyor belt is stored in a box. Other times, you have the opposite. You basically you can pour the content of a box back into a conveyor belt. But the concept of a conveyor belt is important. It is a sequence of bytes. Okay, the bytes are ordered. It is one by one. Question? Oh, okay. So those are the most important concepts of files, at least in the context of this folder. I mean this document. Are there any questions about the concept of a file at this point as a conveyor belt? Okay, no questions. So before we move on to talk about more about conveyor belts, let's talk about how information, basic stuff is represented. How is it stored, in the computer? How is it represented? We talked about binary representation. I hope most of you still remember that. Okay. We talked about how integers are represented as 8-bit, 16-bit, 32-bit integers, right? Okay. We can allocate 16 binary digits and basically look at the entire thing and interpret it as an integer, okay, to represent an integer value. But what about names? What about character? What about names and addresses and all the stuff that we see on the web page? How are these things represented? What is the uppercase A? How is it represented? It doesn't look like zeros and ones to me, but I know that everything has to be stored or represented as zeros and ones inside the computer. So how is uppercase A as a letter is represented? What about the punctuations? What about open parentheses here? What about a period down here? How are those things represented? What about double quotes? How are those things represented? Well, there's such a thing called ASCII, American Standard Code of Information Interchange, okay, which is a really odd name. It came from a kind of early time of computing history. And what it is this. For anyone who has access to a Linux box, you can do something like this on the command line. Man ASCII. Man is the command to look up the manual of something, so that's why it's abbreviated man. And ASCII is a very common topic that people have to deal with because nobody, well, I shouldn't say nobody, but very few people, has the extra memory space to remember the entire ASCII table. So most people just kind of look it up and say, okay, what is the ASCII code of the ampersand character? Well, just look it up. So I'm going to look it up for you, and we'll look up a particular, I don't care which example we use here. Let's use R as a letter, uppercase R. Okay, so we're going to look at this entry here that I have just highlighted. R here, the rightmost column is basically what letter, what punctuation, what digit are we talking about. In this case, we are talking about uppercase R. And the question now is, well, how is uppercase R represented? Okay, what is representing uppercase R? So those three other numbers are basically the same value, but using a different base. Each one is basically using a different base. 122 is a base 8 number. In other words, we can only use digits from 0 to 7 per digit. 82 is just base 10, and then 52 is hexadecimal in base 16. Okay, base 16 is really useful because I can look at a base 16 number and immediately tell you what the bit pattern looks like. So 52 as a hexadecimal number is 01010010 as a binary number. And that is the 8-bit pattern to represent uppercase R. Is that okay so far? Okay, yep, go ahead.
What's the point of using all the different number bases in this representation?
Because sometimes octo is used a lot when you're escaping a character in C and C++. You can do a \0 and then the octo number. So that's why the octo number is represented here. Base 10 is just what we use on a regular basis, and then hexadecimal is the most useful one. I like hexadecimal more than the other bases. It's just a convenience way to give you all the numbers, except for binary because it takes up more space.
Okay, and you said okay.
Yeah, but all of these representations using different bases are just representing the same value, except they're just in different bases.
Okay, that's what I was asking.
Yeah. Okay, but the question is, what do you mean by 0101, 0101, 0010 is representing R? What that means is when you type R on the keyboard and you save it into a text file, that particular bit pattern is representing R. When you transmit that text file to a printer, the printer will look at the same bit pattern, 0101, 0010, and print out as uppercase R from the printer. That's what I mean when I say this particular bit pattern represents uppercase R. Are we doing okay so far with the concept that I'm using an 8-bit pattern to represent, lowercase a to z, uppercase a to z, all the digits, most of the punctuations, and so on?
And how does the compiler interpret the binary number, what you just said, 50 or 52 or whatever, how does it differentiate those ones and zeros between a number that might represent the same ones and zeros?
That's a good question. The question is, if 01010010 is representing R as an ASCII code, how do we know that it's not representing just the value of 82, right? I think that's your question,
Mm-hmm.
right? And the answer is it's up to whatever is processing the file to determine how to interpret that number, or how to interpret that bit pattern.
What do you mean by what's processing the file?
Like a compiler.
Oh, okay.
So when a compiler is processing a file and it encounters, the ASCII code, I shouldn't say ASCII code, and it encounters a byte, which is 01010010, because the compiler is expecting a text file, so it will be interpreting that as an ASCII code, and that's uppercase R. If you're dealing with a binary file, then it's different. If you're dealing with a bitmap file, then it will be different. So the file format and whatever is processing the file gets to determine, am I looking at this byte as a part of a 32-bit number? Am I looking at this byte as a letter? Am I looking at this byte as like in an audio file, as a part of a waveform? So it all depends on the context.
Okay.
The zeros and ones, in a file is nothing more than what you write on a piece of paper. Okay, so when you look at a piece of paper, you either have just the paper itself, or if you use a pencil, you have lead or graphite on it. So the graphite is nothing more than just graphite. It's covering the paper. But how should I be interpreting, whatever pattern is on a piece of paper? It's up to the reader and what the reader is doing with that piece of writing. Okay. So are there any questions about the ASCII table? Let's take a look at something else. Okay, let's look at space, which is really confusing here. Okay, let's look at this particular entry. When you press the space bar in a text file and it saves the space character, this is what it does. Okay, 20 in hexadecimal, which is 00100000, is the bit pattern to represent space, the character space. Okay, it's not exactly printable. I mean, you can see it in a way if you have anything after the space, but otherwise it's not, you cannot see it. Let's look at some of the other odd ones. Okay, let's look at up a little bit here. The new line character. Okay, the new line character is known as the \n. In C and C++. LF is line feet, by the way, and it is represented by 0A as a hexadecimal number, which means in binary it is 00001010. When you send that code to a really, really early printer, okay, remember those printers where you actually have a carriage, it actually rolls around like that? The line feed character actually just rolls the drum. So it's up to the next line. It doesn't even do the carriage return. What is a carriage return? When the whole thing slides around, okay? But in Unix and Linux systems, the line feed character by itself would serve both purposes. So it would both roll the carriage and also do the carriage return at the same time. In DOS, it doesn't do that. In DOS, you actually have to specify both characters. And in Mac, I think it's the other way around. A carriage return implies a line feed and not the other way around. So that's why when we talk about a text file, especially for those of you with a Mac computer, when we talk about a text file, you have to be clear. Are we talking about a text file in Windows? Are we talking about a text file in Linux or Unix? Or are we talking about a text file in Mac OS X? Because the formatting of the end of line is different depending on the operating system. It's just a convention, but yet they're different. And some people have probably noticed a strange one here, backspace. This means, in the good old days when we had, those console, printer/terminal thing, when you send the code, when you send the ASCII 08, which is 00000, I take it back, 00001000 to a terminal, it will do the backspacing. The carriage will go back by one character space. Okay, and you can actually send it to a printer too. This is how people do like boldface in the good old days. Is they keep printing the same character at the same place multiple times. Then it's boldface.
What's the bell?
A bell, it makes the ding sound.
Literally a bell.
Yes, yeah. Remember all those old printers? Typewriters, right? So there's a bell button when you can set it up so by the time it gets to a certain margin, it gives you an audible signal, so that you're almost running out of space on that line. And most people would do the thing to do a carriage return in the line feed. So that's what the bell is for. It just makes a ding sound on the printer. Yep.
How are you getting from the hexadecimal number 08 to the binary?
That's a good question. And the answer is surprisingly easy, and that's why I can do it. Okay, so to do the conversion between base 16 and base 2 is easy, and it has to do with 16 is a power of 2. 16 is 2 to the power of 4. Okay, now that is significant because what it means is 1 digit in hexadecimal is 4 digits in binary. Well, 0 is not exciting, right? I mean, 0 is 0 regardless of the base. Okay, let's move on to the other one that is not so interesting. 1 is not interesting. 2 is a little bit more interesting. 3, and so on. Okay, so let's move on to 8. Okay. 8 is 1000. 9 is 1001 because it's just 1 more than 8. What about 10? Well, what we understand as 10, which is 10 in base 10, needs to be represented with a single digit in base 16. But we only have 10 digits, literally, because a digit is a finger, right? We only got 10 fingers. So what we do is we borrow from the alphabet. We borrow from the A to Z's. So we just borrow the first 6 letters from the alphabet and say, oh, you know what, we're going to borrow A to mean 1010, which is otherwise known as 10 in base 10. But in base 16, it is known as A and not 10. Are we doing okay so far with that concept? And then B is what we know as 11 in base 10, but in base 16, it is known as B, which in binary is 1011. C is 12, which is 1100. D is 1101, E is 1110, and then F finally is 1111. And this table works in either way. In other words, if I give you a binary bit pattern, you can look it up in a reverse way. If I give you, let's say, 1010, 0011, then you just look up the table. 1010 is A, 0011 is 3, so in hexadecimal, that value is known as A3. Okay, so it's a lot easier than dealing with base 10 versus base 2, Because if you convert between base 10 and base 2, you either have multiplication, a bunch of multiplications, or you have a whole bunch of divisions, okay, and you have to track the remainder, okay. This is just a lookup, okay. You group the bits by 4, and then you look up the table to find the hexadecimal representation. Or you can do it the other way. You look at each digit in a hexadecimal number, look up the 4 bits, and just write it down. Are we doing okay so far with the conversion? It's just table lookup. 16 entries in the table.
So 82 would just be 101. Exactly what 82?
82 in hexadecimal is 1000 and then 0010.
Okay.
But you have to remember, the leading zeros are important in this case. So you never write 0010 as just 10, because it has to take up the space of 4 bits. All right, those are all very good questions. I think we are ready for a little bit of command line stuff other than looking at the man page here. So let's go ahead and take a look at a program. I have a lot of test programs here. Okay, so these are some of the programs that we have done before, so we'll just go ahead and take a look at the original code from the perspective of an editor, okay? Do you guys still vaguely remember this program? Okay, now our focus now is not the logic of the program, it's just, okay, this is what we see, okay? But what is really in that file? What is representing all of these characters that we are seeing in the editor? What is the pound sign, the lowercase I, lowercase n, and so on, the line feed, the space, double quotes, equal symbols, and stuff like that? How is it really represented in a file as bit patterns? Well, to do this demonstration, there's a program called hexdump that is particularly helpful. Hexdump, the name comes from hexadecimal dump, which means we want to look at a file, or we want to look at the content of a file, but not as characters, but as individual bytes. Okay, and it is really helpful. I use an option called -C, dash uppercase C. It will try to display content in character form whenever it is possible. When it's not possible, it won't do it, but whenever possible, it will do it. And then we give it the name of the file, which is short.cpp. Now, this will give you something like this, okay? And you can probably do the correlation right away, okay? What you're seeing on this side, this is the internal binary representation, except we're not using zeros and ones, we're using the hexadecimal representation. The only reason why we are using hexadecimal instead of zeros and ones is because this is a lot more compact, okay? Because one hexadecimal number is 4 digits in binary. So if we were to use base 2, this would have been a lot longer, like 4 times longer. All right?
So
go ahead.
Can I ask, 23 is 00100011?
Yes, that is absolutely right. That's the first byte of the file. And then the second byte of the file is 69, which is 01101001. And then the third byte is 6E in hexadecimal, which is 01101110, and so on. In other words, everything is represented by zeros and ones. Okay? Are there any other questions about what is inside a file? Is the ordering important in a file? In other words, if I just kind of mangle up the ordering of these bytes, would it still be representing the same program? No. Okay, so you got to remember that. Okay, the sequence, the ordering of the bytes is significant. It is important. Okay. Any questions up to this point about? Okay, so let me just kind of remind you what we have talked about up to this point. We talked about ASCII code. We talked about a file is basically a sequence of bytes, okay? Sometimes it is stored with a file name inside a folder, and other times it's just nothing more than a sequence of bytes. I haven't shown you an example to illustrate that, but we will still see an example of that. we talked about base conversion between hexadecimal and binary. Okay, because ultimately everything is binary, zeros and ones. But hexadecimal makes it easier to write. Any other questions? Look at all the 2 zeros in this file. This 2 0 is corresponding to this space here. What about the periods? What about this period here? That's the third byte from the beginning of this line. First, second, and third is a 0A. Do you remember what is a 0A in the ASCII table?
0, 0, 0, 0, whatever A is.
It's 1 0 1 0. But what does it mean? You know, what does that represent? It's the line feed character. That's the new line character. So when you see 0A in a file in Linux, it simply means that's the end of one line. All right. So are we doing okay so far with a hex dump like this?
Is it putting those periods in automatically? Because that's not.
Yeah, because they're quote unquote not printable characters, so it uses a period to represent that space that is taking up, but it's not printable. Right. So if there are no questions about this, then we'll start to introduce the concept of a file that has no name and there's no place to store it. Okay? All right. But before we move on to that particular topic, let me show you some of the commands that we can do in Linux. Okay? In the previous class, I used grep, but in this class, I'm going to use WC, which is not water closet for those of you with a British, understanding of the word. WC is not water closet. And just like most of the commands in Linux and Unix, if you don't know what a command does or how to use it, use its man page, okay, which is the manual page of that particular command. So you can use a man page, and it shows you this is print the number of lines, words, and byte count for each file. Okay, that's all it does. It's really just a very simple program to count the number of bytes, the number of words, and the number of lines in a file. So normally you can say WC and then a file like short.cpp. It has to be a text file, otherwise it doesn't make a whole lot of sense. And it would come back with these numbers. This particular file has 15 lines, 33 words, and 169 characters. That's basically what it is. Okay, not a very complicated program. It's useful sometimes, but that's basically just what it does. The question is, what if I just run it with WC, but not with any type of file to specify? Okay, now it's special because the program has not hung up. Okay, it's not broken. It is waiting for me to type something. Okay, so as it turns out, what we understand as quote-unquote the keyboard, the input, is a special file. As far as the program WC is concerned, what you're typing is nothing more than a file. It's a conveyor belt. Okay, whatever you're typing, whenever you type something, you're putting a box onto the conveyor belt. And it will just process those boxes as if those boxes come from a regular file that we understand, that we store on a hard drive. So now I can type something interactively. So I can say this is just a test file to see how standard input file works. Okay. So as I type, the program is silently keeping track of the number of characters, the number of words, and also the number of lines that it has seen. But it's not printing anything because I haven't said, oh, this is the end of the file, give me the total number of each one. Okay? But it is just silently doing all the processing in the background. Okay? But obviously in this case, I don't have a traditional file. Okay? I didn't save all of this stuff into a file. I didn't specify a file name. But yet the standard input file, quote unquote standard input file, is a file as far as the program is concerned. Now, if I press Control D on an empty line, it means end of file. It basically means, oh, this is the end of my input as a file. So when I press Control D on the keyboard, the WC program understands, oh, okay, I can see that you're done with the standard input. And let me give you the total now, okay? You have just typed 3 lines, 13 words, and 63 characters. Okay? So this is the first illustration of what I consider as a file that has no name, it has no place to store, okay? Because what I typed is not stored anywhere. I didn't save it at all. And yet, to the program WC, it is processing what I just typed as if it is processing it from a file. Are we still doing okay so far with the concept of a file? So the key concept is whatever I type here is byte by byte. Just like the ordering of bytes in the file, it is byte by byte. It is represented using ASCII code. So when I'm typing this, uppercase T is represented by the ASCII code of uppercase T. It is transmitted to the file using the conveyor belt, and so on. Okay. So as far as this is all concerned, it's the conveyor belt. It's not where you store the file that is important. It is the concept of it is a sequence of bytes. It arrives byte by byte, or you can transmit it byte by byte. That is important. Are there any questions at this point?
So you're basically saying it's just a series of bytes.
Yes, it is just a series of bytes. Now, if it's an input file to a program, that means somebody else is specifying what to put onto the conveyor belt, and your program is just taking those bytes out of the conveyor belt and process it. And an output file from the program's perspective is exactly the opposite. Your program is putting stuff onto the conveyor belt, it's going somewhere else, but you don't care who's going to get it or what they're going to do with it. Okay. Are there any other questions about the concept of a file? Because this is kind of weird, okay? It's not how we normally understand, is a file. If there are no questions about this, let's move on and talk about some really, really strange files in the Linux or Unix type environment, because you will eventually come across these things, and I think it's related to what we are talking about here. There are several files that are particularly, there are many files that are interesting in Linux. What about the entire hard disk drive? Well, you normally in Windows you look at your drive as C:, right? I mean that's usually your hard drive, and D:, if you have a CD-ROM drive, that's your CD-ROM drive, and then you start with D:, to refer to your USB thumb drive or external hard drive. In Unix, the entire hard drive can be seen as a single file. So that makes backing up an entire drive a very easy thing to do. Okay. I'm not going to show you the commands, because if you mistype that command as root, bad things, very bad things can happen. So I'm not going to show you anything that can potentially kill your entire hard drive. We are not talking about a file or a partition. I'm talking about the entire drive. And a certain command that will make it happen with efficiency. Yes.
Right.
Yeah, wiping your entire hard drive is a single command in Linux. So I'm not going to show you that, but there are certain things that's good about that approach too. You can back up the entire hard drive. You can ghost it using a single command. You don't need Norton Ghost to do anything like that. Right. Let's write a program to make use of standard in and standard out. Okay, just to do something that is related to what we are talking about here. So I'm going to write a program called add.cpp, which doesn't do anything really particularly exciting. I will come back and explain all of this extra stuff eventually, but right now let's just focus on the file concept.
If I can interrupt, ISOstream is not a header file, or is that just the C+ syntax? Like how
It's still a header file. IOstream is a header file.
So, but it doesn't need a .h?
Does not have an extension, that is correct. It's a C++ thing, starting with C++, or the newer version of C++, they do not want people to use an extension for header files anymore, and that's the new clinical convention.
Would if you just put it in there, would it still compile, or would it be like that's wrong?
I believe it would not. It would not be able to find it. And also, header files for C++ instead of C should end with HPP as the extension and not just .h.
Oh, because header C++.
++, yeah. Okay, so we have two local variables x and y, and this is how we can read something from a file, we call standard in, and put it into a variable x. I'm going to read another number and put it into y, and this particular program just wants to compute the sum of those two numbers and print it out, and that's C out, and then we just say return 0 at the end of main, and that's my entire program. Don't worry about this part of the program. I will go back and explain that part. Just kind of focus on this part first, okay? Cin is the name of a particular object or variable that is already declared and initialized for you. And Cin represents what we call the standard input file. Cout, on the other hand, represents the standard output file. So, but remember, these things are just a representation of a file. It is not the file itself. It is basically what you use in a program to refer to a file. So when the program executes this line, what it's really trying to do is to read characters from the standard input file and try its best to interpret those bytes as a number and store that number in base 10. Well, read the number as a base 10 number and then store that number in variable x in this case. So it's basically input. Okay? Input from standard in, put it into x, input from standard in, put it into y, and then as the output of this program, print out x plus y, the sum of those two numbers. Okay? Let's go ahead and run this program, okay? Because it's a very simple program, and most people know what the program is supposed to do. So there's nothing really surprising here. So I'm going to include debugging information here, just in case I want to debug it later on. All right, so we'll go ahead and run the program. And what do you think the program is doing right now? Looking for input, okay? Because I did specify, okay, input from the input file, read into, the integer x and the integer y. So I will give it a number, 45, and it's waiting for the second number, okay, because it just got the first number. So let's say the second number is 78. If I press the enter key now, what do you think the program should do? It will add it together and print it out, right? So unless I do something really funky, it's going to be using base 10 for input as well as output. So the output would be 123, right? Okay, 1, 2, 3 is the output, and that's what it does. Okay, it does 1, 2, 3 here, and because I did not specify a new line, the prompt of the system is right after the output of the program, and that's why it looks kind of funny as 1, 2, 3 user blah blah blah, because well, a part of that is the output of the program, and the other part is the prompt of the system of the command line. Are there any questions about the behavior of this program? No questions? Are you sure? But where's the file of this particular example? I don't see any file. I just type something on the keyboard, it prints it out on the screen, and how is this illustrating the concept of a file?
Is it a temporary file?
There's no temporary file. Standard in is a file. It has no name. It is just what we call the console. Okay? The console becomes the quote-unquote input file if you don't do anything special to say, oh, use that as the input file. Okay? So by default, a program that uses Cin and Cout is interactive. When they try to read something, it's waiting for you to type something on the keyboard. When it wants to print something, it prints it out on the screen so that you can read that something on the screen. So by default, it's interactive. But that also means that there's a way to make it not interactive. Okay, so let's see how we can make it not so interactive. So what I'll do is I'm going to create a text file, and in this text file it has just the two numbers, 45 and 78. Okay, I use VI to create this text file. It's not special at all. This file is just a regular text file, and we can even use hexdump to look at the content just to make sure that we understand what it is. Okay, kind of what you expected, right? 4 as a digit is represented by the ASCII code of 34 in hexadecimal. Now this part is also kind of important. I kind of neglected to talk about this part earlier. When we look at a digit 4, like in this case, which is a digit in a file, 4 as a digit that is printable is represented by the ASCII code of 34 in hexadecimal. Is that okay?
Why?
Sorry?
Why is it represented that way?
It has to do with how the ASCII code is created, because the first bunch of ASCII code is reserved for non-printable characters. So the digits, for whatever reason, start with 30 in hexadecimal. In other words, when you look at the bit pattern, I take it back, 00110000, that is representing the digit 0. Is that okay? Because the digit 0 has absolutely no relationship to the value 0 itself. It's just representing something that the printer knows how to print, that your monitor knows how to display, and also one of the keys on the keyboard. Whether that really represents the value 0, hey, it's just what we want it to do, right? It's just like spelling out zero. That's 0 to us, okay, in English. But if someone has no exposure to English, they look at the letters zero, it has no meaning. So for exactly the same reason, a digit is nothing more than something. So, okay, this is a perfect example. When you see this 4 here, it is simply because it is understood that 34 in hexadecimal is representing the digit 4, and that's why it's printing 4 on the screen here. Okay, when you press the key 4 on the keyboard, that is transmitted to the program. Okay, 00110100 is what is transmitted to your program. Now, how your program wants to process that ASCII code is entirely up to it.
But if it doesn't necessarily represent the value of 4, how do you do calculations with it?
You have to do you have to do a conversion first.
Okay.
Yep. Which is automatic with cin. When we use cin and then the greater than symbol, that base conversion from base 10 to the internal representation, which is base 2, is automatic. So that's why it understands, oh, you mean the value, 45 and the value 78. The 0A we talked about already, that's just a line feed character. So we have 2 lines here, 4, 5 on one line, and then a line feed character, 7, 8 on the next line, and then another line feed character. Now this is the part that is kind of interesting, because when we run exactly the same program as before, this time instead of just pressing the enter key, I use the less than symbol, which is also called the redirection symbol, and now I can run it without typing anything. The redirection symbol is basically telling the computer, telling the operating system, and say, go ahead and run add as a program. But this time, instead of waiting for someone, a user, to type in the number interactively, get it from this particular file. As far as the program is concerned, it is still a conveyor belt. It's just who is putting stuff on the conveyor belt. Before, it is an end user typing something, and the typing is what is putting stuff on the conveyor belt. This time, it's basically saying, oh, go look at that box over there, and pour the content of the box onto the conveyor belt. And that box is input.txt. It just so happens to have the content of exactly the same thing. So when I press the enter key, this time it's not interactive. It's not waiting for me to type anything, because it is getting the content directly from a file, input.txt. And it will just process it the same way as before, because you can see that it prints 123 as the result of running this program. But I can do something even more fun, because I can make it non-interactive altogether. Okay? In other words, not only is this program not interacting with the user as far as specifying the numbers to add is concerned, it's also not printing it out to the screen. The greater than symbol is also a redirection symbol, but instead of redirecting the input so that some file is providing the input to this program, this time I'm redirecting the output also. Okay? In other words, instead of printing the output to the screen, let's capture that to a file. So if I do something like this, output.txt, and run the program, It has no indication whatsoever that it did anything. Okay, it didn't crash, but there's no indication that it did anything. That's because the output of this program is no longer printed to the screen, which is normally what it does, to interact with an end user. But using the redirection symbol, the output of this particular program, which is also known as standard output, is now captured into the file called output.txt. It's basically the same conveyor belt, except instead of having an end user on the other side of the conveyor belt and looking at 1, 2, 3 as the result of the calculation, it is now, the content is now packed into a box. And that box is called output.txt. But as far as the program add is concerned, it still has two conveyor belts. One conveyor belt to feed into the program, and the other conveyor belt to go out of the program. And as a conveyor belt, once again, the ordering is important, and each item on the conveyor belt is 1 byte. Are there any questions about what I have demonstrated today? The syntax part, if you read the notes here, I have all the stuff already basically written down. The classic Hello World program, using standard IO, std.io, and also the alternative, which is using cin or cout, just cout in this case. And this one also explains what is using namespace std. So you have to read the notes for the details, but the concept is kind of more important in a way, because a file is not what you normally think is a file. Okay, it's just a conveyor belt. Right? Any questions? Didn't I tell you files are boring? It's just a conveyor belt. I don't know who's putting boxes on the conveyor belt, and I don't know who is processing the boxes out of this conveyor belt. It's just a conveyor belt, right? All right, so we are running out of time for today. I'll see you guys on Wednesday.
I did it.
And we can start to do something fun on Wednesday.
Oh, yeah.
So,
Can I see the attendance?
Yep.
I think I'm turning off her off bit.
so